So first of all, welcome everyone to this Birmingham Tech Week webinar. The title of the webinar is Kickstart the Green Recovery with Midlands Greentech. We've got a couple of speakers today, one who will look backwards on the history of power generation in the Midlands, and myself, I'll be looking forwards to kickstarting the green recovery in the Midlands. Just a quick thank you to our sponsors, our Greentech sponsors for this presentation. We're working with Steam House at Birmingham City University, where they're incubating small businesses, mostly digital and web-based businesses, but also Adlan is working with Steam House to develop a Greentech incubation process, which includes fuel cells and hydrogen businesses. Odyssey is Andrew Lowndes' business, which is really focused on producing historical presentations and also documents around innovation and science in the Midlands. And then Adelan, we're a small fuel cell business in the fuel cell and hydrogen sector, which is rapidly growing right now. And we are going to be talking about the future of green tech. So just to walk you through the programme today, first of all, just a brief welcome. And then we'll introduce the speakers shortly, who will be Andrew Lowndes and Michaela Kendall. We'll take questions from chat box. If anybody wants to ask anything, please do use the chat box there. And if you could switch off your microphones and also video during the presentations, I'd really appreciate that. Okay, we're aiming to wrap up at 1:30. Okay, so let's start with the presentations.
I sell here, sir, what all the world desires to have, power. The words of Matthew Boulton in 1776, humans need power. The first energy source we actually had was fire, developed a long time ago, probably by accident, but fire meant we had cooked food, which developed our intellect. And also, for the first time, we could develop industry. We also could get power from the wind, these vertical windmills from 700 AD in Persia. These evolved into the windmills that you fully understand to this very day. They serve a medieval design, driving machinery. But also there was water power. Flowing streams and rivers could drive large wheels, which then in turn could drive machinery. But these varied. In summertime, they could dry up, for instance, or they could get clogged in winter. So it wasn't a regular source of power. On the land, there was horsepower, pulling the plough, pulling carts and so on, because mankind needed power. Energy is vital. Here we can see a forge with men, blood, sweat and tears literally being used here to forge materials that were needed. Birmingham was growing in the 18th century to one of the great towns. It was guild-free, so it attracted skilled people from all over Europe into the region. There they could use their skills and set up manufacturing on their own basis. People like Matthew Boulton, he inherited a buckle and button making business and wanted to expand, and being in Birmingham, he could. He also had access to great skilled workers, which he all brought together in Solihull manufactory in 1762, the largest manufactory in the world. They worked there and he had his own sales department to sell the goods. Water was supplied through Hockley Brook, which drove a water wheel in the centre of the manufactory. And he actually had reservoirs which would be filled up to drive the wheels when the river or the stream dried up. But he needed a pump to refill those reservoirs, something efficient. Steam pumps were available, and although many people think James Watt invented the steam engine, he did not. Hero of Alexandria developed the first steam engine, a small turbine, and also used it for interesting toys. Nobody needed the steam engine in the 2nd century AD, so there was no call for it. But from the 17th century onward, steam engines were used as pumps and were quite vital for everybody. James Watt, a scientific instrument maker in Glasgow, was known to Matthew Boulton, and Boulton had actually advised him on his developments. He was well known. He'd already surveyed canals in Scotland, but working for the University of Glasgow, he was given the model of a Newcomen steam engine to repair. The Newcomen steam engine of 1712 was the standard pumping engine used in the day. And this is what Matthew Boulton was planning to have, although he didn't think it was efficient either. Boulton James Watt realised he needed to modify this engine and set about to do it. The big problem was mines. The Newcomen engine was used to pump water out of mines, but once the mines got deeper than 80 fathoms, the engine was useless and mines had to be closed. So mine engineers wanted better quality pumps. John Roebuck, a mine owner, funded the experiments until unfortunately he went bankrupt. Owing money to Matthew Bolton took interest in the steam engine in lieu of payment because he needed a pump. Now, the steam engine developed by James Watt was remarkable. The bottom line was the cylinder has to be kept hot. So he fitted a separate condenser. He sealed the cylinder perfectly. And also the cylinder had a perfect circular form developed by John Wilkinson, who had a boring machine. This made this machine 5% more efficient than a Newcomen engine. The control of the engine was absolutely vital, and in fact it could run away itself. So he developed special techniques to control the engine, the great cylinder, of course, a centrifugal governor, and of course a control mechanism. He also had a counter on board, and this could calculate the amount of coal being used. Bolton immediately realised that this was the most efficient steam engine in the world. We could make money on this, and set up a company and a partnership with James Watt. They also had, of course, William Murdoch, a Scotsman who came down from Scotland to work with these two men. In fact, best day's work Bolton ever did was hiring this man, a brilliant engineer in his own right. So the company was formed, and now the steam engine was made available to everybody. Rotative motion was added, and this changed everything in the world. Factories no longer needed to be built near watercourses and streams because you had rotative motion. You could have 24 hours a day systems if you wanted to. The Bolton Watt business model was also unique, advertising the new engine by the demonstration of a scale model. Engines would be erected at mines and mills by workmen supervised by their own man, William Murdoch. The engines were to be leased. They were too expensive, £1,000 each. So the lease would be paid for by calculating the amount of coal saved using Watt's design over the Newcomen engine. Design of engine and components were protected by patents, and the application of the engine was prohibited by use of the patents as well. And component suppliers were given exclusivity of supply. So they controlled the supply chain. This was vital, and this was a brilliant method to actually manufacture the engine. The engine was used, of course, for all sorts of things, for minting machinery, for instance, producing coinage on a massive scale. They built their own foundry in 1796 in order to manufacture steam engines from scratch. And now the world changed because the Industrial Revolution had power, exactly what it needed to drive it forward. And the world never looked back. Chimneys sprung up around the world as factories produced more and more goods using James Watt's steam engine. Belts now appeared everywhere. Mechanism had arrived. The company was taken over by James Watt Jr. and Matthew Robinson Bolton, and they expanded into boats and ships, developing special steam engines, including the engine for the screw on the Great Eastern, the largest ship in the world built by Isambard Kingdom Brunel. Richard Trevithick, a Cornishman, developed the steam engine for use on railways. And here you can see his early engine, the ultimate of which was the A4 Gresley Pacific, the world's fastest steam engine. With the cities growing, thanks mainly to the development of steam power, cities now were flooded with people who were employed in the factories. London, for instance, was filled with people. And the basic mode of transportation on the streets was still the horse-drawn carriage or the horse-drawn omnibus. Take this as an example. In London, in 1900, there were 50,000 horses with hansom cabs. Now, the horse produces 1 litre of urine a day, which therefore, with 50,000 horses, is 18.25 million litres a year. They also produce up to 15 kilograms of manure a day, which means nearly 274,000 kilograms of tons, I should say, of it per year. And there's the death of a horse. 3 horses a year die. All this material has to be disposed of. And the problem had occurred that in the major cities of the world, not just London, there was a real problem, an ecological problem of dealing with all this material. You couldn't give them in your way. Farmers were paid to take it off their hands. Something had to be done. Take the urine, for instance. The urine seeped through the ground into the basement of the buildings. This was corrosive, damaging brickwork, causing a great deal of damage. In London today, if you go down into the deep basements of some buildings, this urine from all those years of horses is still seeping through and causing damage. It has to be pumped away. They needed a solution. They needed to find a way to replace the horse on the street. William Murdoch had developed a steam carriage, but it wasn't that wonderful, to be quite honest. Eventually, in the 19th century, these magnificent carriages were actually built, these huge steam vehicles. They weren't overtly efficient, and there were a number of accidents. They needed something lighter, better, if possible. Rudolf Diesel had worked on an internal combustion engine. His engine was designed to replace the steam engine. It's actually more efficient than the steam engine. And again, we're down to efficiency here. So he was hoping that this could actually slowly replace the steam engine in factories. Nicolas Otto developed the petrol engine, a much lighter weight internal combustion engine that could be fixed to vehicles like the Carl-Benz Motorwagen. Therefore, you had an alternative perhaps to horses. But working with these was also the battery vehicle. So batteries here in sequence being used to drive a tricycle. And the advantages, of course, because they were electricity, they could have electric lights on the vehicle as well. These technologies started to be developed in parallel and being put onto the streets. Here is an electric carriage being used on the streets of London. And what a magnificent looking vehicle. Simple to use, it was clean. Interestingly enough, in 1912, 1/3 of all hansom cabs being used on the streets of London were electrically powered. And the electrical system seemed to be working extremely well. What changed was Henry Ford. The American, who was a revolutionary in his own way to develop manufacturing, especially of the motor car, was promoting the motor car. And he had to, it was his business. But it was also part of the policy of the United States, who discovered oil on their territory and wanted to economically exploit the oil. The best way to do it was to sell the motor car. So Ford, with political backing and large finances, started to push the motor car, not just in the United States, but in Britain and Europe, taking out special advertisements. How about this? Here's an electric car being charged by a lady driver in 1912. This isn't simply an advert for the electric car. This is Ford promoting his vehicles. His attitude was, in a very sexist advert, the petrol car and the gasoline car, as he called it, was for men. And the electric car was for ladies. And because they had the power and the money, they squeezed the electric car out of the market and it disappeared. The result of that was what we have now. In London, in 2018, 2.6 million cars, producing 4.75 tonnes of CO2 per year per car, 12.5 million tonnes of CO2. We've now reached the ecological problem that we had with the horse. Only now it's the CO2 and other noxious fumes that comes off of vehicles. This is the problem we have now. It's interesting to think that the pathway to power could have gone on a different road. Had we done so, it might have been different. Joseph Priestley and James Watt were working on the composition of water. Priestley had discovered oxygen. Lavoisier had identified hydrogen. And this is the composition of water. And James Watt made a very prophetic statement. The reactive oxygen and the flammable hydrogen may one day provide a source of power more efficient than the steam engine. In fact, he was quite concerned in the 18th century that a source of power, an internal combustion engine based on oxygen and hydrogen, might actually replace the steam engine. It never happened. It was not till the 19th century that William Robert Groves, a Welshman, a medical doctor and lawyer, developed what we now call the fuel cell, his gas battery, a remarkable piece of equipment. He demonstrated it in Birmingham at the British Association for Advancement of Science meeting. Present at the meeting was Michael Faraday. From this, he laid down the principles of electrolysis, and a new technology began to develop.
I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the Earth. No single space project in this period will be more impressive to mankind or more important for the long-range exploration of space, and none will be so difficult or expensive to accomplish.
The moonshot gave the fuel cell its opportunity. The fuel cell had been being developed from the 1930s onwards by Francis Thomas Bacon. Using his own money and his own time, he developed a remarkable device, the alkaline fuel cell. Oxygen in at one end, hydrogen in the other, producing an electric current. The byproduct was water and heat. This was ideal for the space program. General Electric had developed their own fuel cell used on the Gemini program, but it hadn't been that successful. In fact, it was the Bacon fuel cell that was the way forward. It was used in the Apollo command and service module. The water was used for drinking, well, as drinking water for the astronauts and for the air conditioning system. The heat could be used to heat the spacecraft, and surplus heat would be irradiated out into space. It was just perfect for what they needed. The Bacon fuel cells, 3 of them used on the Apollo vehicle, were magnificent. In an Apollo vehicle, in a spacecraft, you have a enclosed environment, so you need a clean, efficient power system. The space shuttle, when that went into space, also used a variation of the Bacon fuel system, Bacon fuel cell system, which had been developed even further. And now on the International Space Station, the next generation of the Bacon fuel cell is being used. Rather magnificent. You see, the space station is like an artificial planet, if you like. You have to breathe and you need water and so on. But you can't have noxious fumes or gases. It has to be a clean environment. And this is where we're learning how to do just that. On the Earth, it's such a big planet, we didn't take much notice to what we were doing until perhaps recent years. But on the space station, it became obvious. And the solutions to clean energy had to be found, and they were there. Birmingham today is still a city of innovators. Some great innovations are still being done in this city, not often shouted about just enough as they need to be, but they're there nonetheless. And now there is a great opportunity for Birmingham again. It took the lead once before in the 18th century. Now it's its chance to take the lead again. A new moonshot is here, only this moonshot is to try and solve the ecological problems we have in the need for power, green technology. This opportunity is here and now. Now is the chance to set sail to a new sea, and that new sea will involve green technology. Thank you very much for listening.
Thank you, Andrew. It's a really brilliant presentation there, illustrating what the region contributed to the world in the past to green tech. I mean, it really demonstrates a unique innovation capacity in the region to generate hardware. And now we're looking at the generation of green tech, hardware and software. What can we do to kickstart the green recovery with Midlands Green Tech? And who could be the next Bolton and Watt of green tech? I'm CEO of Adelan, one of a couple of fuel cell companies in the region. We're the longest running fuel cell company in Britain, and like Francis Bacon, we work closely with the US to deliver this technology to market. We co-wrote the foundation documents for the fuel cell and hydrogen joint undertaking in Brussels, a 2.5 plus euro programme to bring fuel cell and hydrogen products to market readiness by 2020. I worked at the UN Hydrogen Centre in Istanbul from 2002, developing the hydrogen economy in developing countries. Now I chair the Midlands Fuel Cell and Hydrogen Network. This is a trade body for fuel cells and hydrogen, and I'm also the Mission Innovation UK Hydrogen Champion for the UK government, based out of Bays. So since April, I've been chairing the Low Carbon Steering Group at the Greater Birmingham Solihull LEP. This is the voice of the low carbon sector, the green tech sector. We're just starting to work with the Commonwealth Chamber of Commerce to promote exports and develop good local procurement practices here so that Birmingham buys from and supports local businesses offering low carbon solutions. So the green recovery, what is it? Why do we need it? And why is it not already happening? Well, COVID-19 broke business as usual, and we all saw that if we pivot our energy systems towards low carbon, we can prosper in many ways. COVID offered us a moment to reset and recover, to build back better, to retire old polluting technologies and install green tech. Nobody should be installing dirty diesel engines in this city centre anymore, especially those funded by the public purse. We were already looking for an exit strategy from the carbon economy. COVID focused people's minds and brought people together on the ground to tackle the next looming crisis, climate change. We already knew we needed to accelerate the energy transition locally, away from carbon. So what should the response be? Well, internationally, everyone is accelerating green initiatives, building back better, investing in green tech. The UK needs to act radically to attract private investments as smart investors shift towards green tech businesses. Local green tech businesses will lead the supply of local solutions. We cannot just be working on demand side policy. We can make things. So why do we need a Birmingham Green Recovery? Why support green tech businesses? I've got 3 good reasons. The first one, it's an emergency. Like the pandemic, climate change was not taken seriously at first, and the virus was only controlled by serious changes in 1, behaviour, and that resulted in lockdown, and 2, fundamental technology R&D into vaccines, treatments, protective equipment. Unlike the pandemic, there is no vaccine, no quick fix, and reaching net zero will be a long, difficult, long-term goal. We need every green tech tool in the box. The second reason is it's the law. Net zero in the UK is the law by 2050. The third reason is that Birmingham has a unique innovation capacity. As Andrew said, Birmingham has always had a unique role in delivering innovations to market and can break down the market barriers which exist to low carbon, engaging with real customers, proving affordable technologies in living labs like in this incubator at BCU. Global emissions of CO2 are growing and we need fundamental technological change. As China and India grow, they both need to generate more power and yet with less pollution. Fundamental changes in the way we use energy and generate it require innovation. Behaviour change will not be enough to address areas like metal production and construction. This is just not about inventing things in universities. The manufacture and commercialisation of these products is critical, and we need the green tech Boltons and Watts to grow businesses that deploy these technologies fast to achieve net zero. They would not have succeeded in universities. We need to build commercial cases. So why didn't it happen already? Scaling green tech is critical to both lowering costs and also delivering carbon impacts. So low carbon transition is a hardware problem to remove carbon emitting technology. Deployment is slow, especially the scale learning curve that solar, batteries and wind have all gone through. Look at the case of solar. So solar is now a success story, but the solar technology was ready 25 years ago. It just didn't have a market, nobody would produce it at volume and the costs were high. We need to speed up this scale learning curve and explore every green tech tool in the box. The Midlands innovative manufacturing base needs to combine with investment to scale low carbon businesses. Nobody expects commercialisation to happen in universities. Universities can support early market trials, as should all public funding, but technologies are emerging and we need to markets for those technologies, supported public spending to create green tech markets. We need to explore all green tech options to deploy a market test to urgently commercialise and scale them. Just like we tackled the COVID crisis, we need the same response for climate change. So we need breakthrough products to address climate change, and tech companies love a challenge. Innovative products really surprise markets, but there are still barriers even to the best green tech. So we need to increase market testing and accelerate getting products out there. The carbon transition takes time, and sleepy national policies still get in the way. Look at fuel pricing in the UK. UK diesel remains subsidised by UK government until April 2022. Diesel and nuclear are heavily subsidised, and yet we need to support every green tech tool in the box equally, just as the pandemic required us to examine every option to quell the spread and impacts of COVID. Low carbon technologies can only scale faster if their funding is levelled up with competitors. Green tech needs a level playing field to proliferate. So who can deliver this to market? Well, local government could support local businesses, fund green tech, test in local markets. Ultimately, businesses must take a central role in delivery of green tech to market testing with real customers. If local businesses supply solutions, they create jobs locally and strengthen and stimulate the Birmingham economy. If we don't support the businesses here, investments benefit other regions and countries. The local industrial strategy established a framework for green tech businesses to be supported. We must align cross-party support to solve climate change. We must use every green tech tool in the box. So what technologies offer the most promise? And what are the leading Midlands green technologies? So Adelan is pioneering flexible fuel cells in the Midlands. So first, a few words on fuel cells and hydrogen technologies. It's important to think about the hydrogen economy, and it's important to think that there are really two separate complementary business cases here: the hydrogen fuel and also the technology that uses decarbonised fuel. Both are global and scalable business cases. So at Adelan, we pioneer hydrogen-ready fuel cells, but they are future-proofed because they operate on common fuels today, like biogas, LPG and methane, but also on hydrogen where available. So here you can see a range of different applications that the fuel cells can be used in. There's the remote and portable fuel cell generator, top left, and then the sailboat, camper van, and in cars it can provide auxiliary power, but also heat to vehicles. Now I'd like to show a short video of how Adlan fuel cells can be used today.
Dirty diesel generators are used to provide off-grid energy. However, they are noisy, smelly, emit lots of carbon, and are costly. Diesel is so expensive that it is currently subsidised by the UK government until April 2022. But this doesn't have to be the case. Adelan has a proven clean energy solution which generates low carbon electricity and is cost effective. Adlan Ace provides you with portable clean power which can almost eliminate fossil fuel. When fueled with clean gas like biopropane or hydrogen, the Adlan Ace can recharge batteries in cabins on construction sites to enable off-grid activities, catering outlets at festivals or markets, camper vans to power the essentials on holiday, remote locations like an outdoor studio. Adelan's Ace is a game changer. It reduces more than half your fuel costs when compared to diesel, reduces carbon by up to 98%, reduces noise pollution, and reduces hassle, maintenance, fuel deliveries and fuel spills. Visit our website to learn how you can use the Adlan Ace and play a part in the green recovery.
Adelan co-founder Professor Kevin Kendall, FRS, founded the National Fuel Cell Centre in Birmingham and saw it through 2 successful cycles of funding. Adelan supported trials of the first fleets of hydrogen vehicles in Birmingham, the first trial of battery vehicles in Birmingham, the first hydrogen filling station in Birmingham, and the first portable fuel cells in the world. We have further trials planned, and I'm really excited to announce today that if you want to trial a hydrogen car in Birmingham in the next month, you can now lease one from us. Birmingham City Council opens the first public hydrogen station this week, making hydrogen cars for everyone in Birmingham possible. Adlan also chairs the Midlands Hydrogen and Fuel Cell Network. In 2017, we set up the regional trade body representing all stakeholders in the area from the ground up. We worked tirelessly to maintain a continuum for the industry in the Midlands, and this platform interacts with other groups to create a national plan. Climate Change Solutions, based in Coventry, still run the longest running and largest fuel cells and hydrogen conference in the UK, now in its 16th year. Rex Harris from the University of Birmingham had the first hydrogen boat in Britain, paid for by himself. Adelan produced the first portable SOFC, Intelligent Energy, the first fuel cell powered light aircraft. There are so many firsts for fuel cells and hydrogen in Birmingham, and it's really important that we record these. We wrote the first UK fuel cell strategy, and this pulls through technologies like biogas, batteries and solar in hybrid systems. There are end users like Aston Martin for cars, JCB for off-road vehicles and Alstom for trains. University spin-outs benefit from the concentration of regional public assets, such as MIRA, MTC, university labs, like the Birmingham Fuel Cell Centre. This year, we started the Midlands Fuel Cell Incubator at BCU with Steamhouse as a living lab trialling fuel cells with real customers at Millennium Point. You can see a fuel cell, you can join meetings and meet with the Midlands network. So what other promising green tech businesses are out there in Birmingham? So CNG Services and Severn Trent are pioneering biofuels. Severn Trent already supply themselves 50% renewable energy today and have a target to achieve net zero by 2030. Biomethane is a big step forward towards the circular economy, and hydrogen opportunities can create the circular carbon economy. Market testing these technologies is a key focus, and success in these areas will be transformative and world-leading. Biogases provided by CNG Services decarbonise our homes and large vehicles, for example buses and heavy goods vehicles which can't be battery powered. The Low Carbon Fuel Centre at Aston University is looking at biofuels, synthetic fuels and hydrogen trials for freight, buses and boilers. I've made this sound really easy, and it isn't easy, but the thing is that Birmingham is really leading the country in this area. So digitised and Wi-Fi enabled energy is really a massive opportunity. For example, Grid Edge, fantastic way to cut carbon, save energy and be flexible. Just increasing the visibility of low carbon options and their pros and cons through websites like Zella informs markets on the appetite for green tech. Green tech needs the digital tech community now to collaborate on offering minimum viable products. Wider Wi-Fi connection and product digitalisation leads to improved performance and optimisation. Both Grid Edge and Adlan both use web-based platforms and software to enable and improve products to trial to reduce carbon, save fuel and create other benefits. So interacting with customers is the impactful part of the development process, and we are keen to tailor systems to meet customer needs and to trial them with real customers. As I said, tech companies love innovation. Mega projects like HS2 and Commonwealth Games, public bodies like universities and local authorities like WMCA and Birmingham City Council can create low carbon markets and use early trial data to create a green tech pool, create a legacy like the Victorians did. Right now, there is a heavy reliance on imported technology, and we're really missing an opportunity to support local businesses. So this is one of the more controversial green tech offerings that Birmingham has, but I think it's important to mention it. Birmingham University has been the centre of nuclear R&D for 50 years. The Birmingham Centre for Nuclear Education and Research is a national centre, and Professor Martin Freer, the director, is explaining on the website here, which I've captured this morning, talking about the importance of nuclear power to Britain and the region. And really, this is where nuclear R&D is done in the UK and taught. So the business case has never been compelling, but the strategic importance of nuclear to the military and to medicine means that BEIS, Business, Energy and Industrial Strategy Department of the UK government, still has nuclear power firmly on the table. They fund it enormously, and that's even after Japan and Germany have rejected it moving forwards. But I think it's really important to understand that nuclear will be a part of our future, of our important part of our green tech future, And this is a debate that really needs to take place if we're to consider it in Birmingham. So what does Birmingham Greentech need? Well, public spending prioritising Birmingham Greentech. So when a convergence of innovation, need and quality industry occurs, you still require government investment to support green tech. So Midlands Greentech needs support from London. When the Midlands 2018 proposal for a fuel cell centre was rejected by BEIS, it weakened all the fuel cell and hydrogen businesses in the region, weakening the UK at this critical time, promoting other regions and countries above the Midlands, despite proven capacity to lead. The central government has not really supported UK fuel cell and hydrogen technology until now. Around 20 million per year has been spent on hydrogen and fuel cells in total over the last 5 years. Only £1 million per year has been spent on UK fuel cell technology, which means that we're importing pretty much all of the fuel cells that are in BEIS funded programs. The second thing is that why would that be? I mean, how could you ignore the fuel cell technology and hydrogen technology winners and leaders in this field? Well, basically, the talent in the Midlands has not been recognised in BEIS, most notably because of a lack of inclusion, which is a well-publicised failing in BEIS and Whitehall. Birmingham was rejected in the recent low carbon deployment programme to decarbonise industry, but thankfully, repowering the Black Country has succeeded with a small project. It starts in January, which is very exciting. We think that we can, in Birmingham, benefit from this and also exchange ideas and exchange technologies and best practice, because levelling up requires investment into talent to create a net zero economy. Green tech manufacturing businesses in the Midlands need support to succeed. For the UK to announce a climate emergency and then simply wait for others to produce technology solutions and import them does not make sense. Local businesses are ready to create the hydrogen economy and reshore manufacturing. Local procurement by Birmingham City Council and WMCA and HS2 and Commonwealth Games needs to support those businesses to innovate. We need to use our world-class innovation ecosystem, just as Andrew described, to produce the businesses that change the world, just like we are mobilising resources to address the pandemic. This is about UK technology leadership in a global crisis, just like in the pandemic. China has already successfully commercialised 2 other world-class green tech, solar power and batteries. They've resourced strategic green tech to succeed, as have other regions like the US, Japan, Korea. China just announced that by 2021, 80% of public service vehicles, that's buses, taxis and trucks, will be new energy. That means battery or hydrogen. So China creates markets using public funding, could be contracts for difference, for example, in the UK, and WMCA and Birmingham City Council should be doing the same using local contracts. So no project should rely on deploying UK government subsidised diesel or imported technology. There are massive opportunities in Birmingham to demonstrate vision in 3 local mega projects, the Clean Air Zone, HS2 and the Commonwealth Games. So just yesterday, the LEP steering group chair agreed to an industry-led action plan aiming to attract investment and talent to the region, building products to export around the world via the Commonwealth Chambers of Commerce. We are asking, where are the green tech opportunities in public funded projects and in local or mega projects? Low carbon businesses must grow to meet the UK's 2050 climate change and local industrial strategy targets. Businesses create zero carbon jobs and supply value chains. Public investment must support the transition needed. Local public institutions can support local business through procurement, inclusion, engagement to compete internationally with Japan, the US, Germany and China, where governments invest in green tech. The Midlands has got the right ingredients. Adlan is coordinating some of these assets and is asking local and national government to support to achieve net zero. Local public institutions like the LEP need to lead by example, be the exemplar and commit resource to green tech. Local authorities can up their carbon game by supporting local businesses. So how do we enact the Midlands Green Recovery? What does Birmingham Greentech need? Well, when you have a convergence of innovation, need and quality industry, you still require government investment to support green tech. That may be locally, regionally or nationally, and also internationally. It also needs leadership and inclusion. In the pandemic, female leaders excelled in managing COVID, yet green tech is not inclusive. We need to support female and BAME leaders better because we need diversity of thought and approach. Importantly, in the global pandemic, female leaders were the standout success story in national ability to manage and curb COVID. 8 out of the top 10 leaders judged to have been successful on the critical measures were female. Birmingham is a young, ethnically diverse city. We need to use our strengths and young talents by creating green tech opportunities. And the final point for me is that access to finance and investment is critical to scaling green tech and making it successful. This is the critical missing link in the UK as identified last week, and investors in the UK are still not investing sufficient funds in green tech. The scale and persistence of capital is critical. Green tech needs patient capital, sometimes even fundamental R&D money. Corporate and social responsibility driven financing can include green bonds, lower interest rates. Offsets of carbon must be rejected. Just pay for carbon credits or renewable energy credits. These mechanisms are discredited. Finance needs to raise the bar and not succumb to greenwash. This year has seen massive capital raises internationally for key green tech businesses like Nikola and Nell, and risk has been shown to have rewards. So what can you do to kickstart the green recovery? Here are a few suggestions.
How can you help deliver this green recovery? Well, you can apply consumer pressure. This is the most significant act you make. The pounds that you spend count. You can go to your politicians and you can ask, what are they doing about green energy in the region, in your constituency? You can ask your local councils to invest in hydrogen and fuel cell technologies, for example, in public transport, in light rail, in buses, and even in the rail transport system. And you can talk to your financial services providers and ask them, the money that you've invested, where is it going? Who is it held by? And is there a greener alternative? If you want to find out more, please go to the Adlan website, adlan.co.uk.
It just remains for me now to thank you for attending the webinar today. Thank you very much to Birmingham Tech Week for organising the platform and for making this as smooth as possible. I'd also like to thank Andrew Lowndes for his presentation, which was really thoughtful and informative, and Richard Scott for hosting at Steam House, at the Steam House Incubator at Millennium Point. Thanks to everyone for attending. I don't see any questions at the moment, so what we'll do is answer any questions by email or contacting our website. So that's adlan.co.uk. So thanks very much and enjoy the rest of Birmingham Tech Week.